All right, let's continue our review for the Unit 1 lecture exam in astronomy by talking about lesson number 5 on the science of astronomy. So here are your lesson objectives for the exam. And this corresponds to Chapter 3 out of your textbook. So first you got to understand what gravity is. So we've already mentioned that if I take this thing and I let it go, it is pulled towards the Earth by the force of gravity. It's the force of gravity, so F, and then we'll put a G down here for gravity, is going to be equal to some fundamental constant of the universe, which we don't care about, but you can see how big that G thing is. So it's not important, but it's a fundamental constant of the universe. It depends on the mass of particle 1, and then the mass of particle 2, and then divided by the distance between them squared. All objects in the universe are pulling on every other object in the universe using this formula. So you have a certain amount of mass. Okay, then a pencil has a certain amount of mass. You are being attracted to that pencil because of this formula. Okay, you don't normally notice it because the Earth has such a large mass that it drowns out everything else. And so we normally only talk about the force of gravity of the Earth pulling on everything. But just remember that every object in the entire universe is pulling on every other object in the entire universe according to this law. Also notice gravity is attractive. That's what the negative sign means. Gravity never pushes something away. So gravity is always attractive. That's different than electricity. So in electricity, you could have situations where two objects push each other apart, or two objects can pull each other together, like magnets. But gravity is always going to be attractive. So here's the kind of question that you should be able to answer. If two objects get 4 times further away from each other, what happens to the force of gravity? So the R is going to change. So the R is going to get 4 times bigger. So you might be tempted to say, well, if it's 4 times bigger, then the force of gravity is going to get weaker by a factor of 4. But you forgot to square it. So it's 4 squared. So therefore, gravity is going to get weaker by a factor of 1/16. So you could either say it's 16 times weaker or 1/16 as strong. So either of those two answers would be okay on the exam. Okay, then the tides. All I want you to know is, what do the tides look like? So if you were to draw a picture of the Earth, and then let's put the moon over here, then the gravity of the moon is going to cause the water to do this. So it's going to mound up on both sides of the Earth. Okay, you should be able to explain why. So in class, we did the thing where people stood shoulder to shoulder. Okay, and then the gravity of the moon is going to pull on this water harder because the distance is the shortest. The shorter the distance, the greater the force of gravity is going to be. Okay, but then the Earth is also being pulled on by the moon. But notice the distance is larger. And then finally this water over here has the largest R, so this water feels the least amount of gravity. but all three of them are being pulled towards the moon. It's just that this one doesn't move as much because it's so far away. That was the very simplistic explanation for the tides. So if you want a more detailed explanation for what causes the tides, then take a meteorology course on that. Also, you should know it's not just the water. So the moon pulling on the Earth itself. The Earth stretches as a result of the gravity caused by the moon. The air, the atmosphere of the Earth stretches because of the gravity of the moon. But it's more. So for every action, there's an equal and opposite reaction. So if the moon is pulling on the Earth, then the Earth is pulling on the moon. So that means that the moon is also stretched a little bit because of the gravity of the Earth. Okay, so this is very important because it can actually pull a moon apart. So here, the gravity of the Earth pulling on the moon. If the moon was to get closer to the Earth, the R would get smaller, so the force of gravity would get stronger. That would mean that this moon would be stretched even more the closer it would get to the Earth. There's a limit called the Roche limit. So let's say that that's the Roche limit. If this moon gets any closer than the Roche limit, then the gravitational tides would stretch that moon so much that it would pull it apart. Okay, you don't need to know about the formulas for the exam, but you do need to know what the Roche limit is. Another thing that it can do is it can cause the moon to move further away from a planet. So our moon is actually moving away from the Earth at a rate of about 1 centimeter per year. You don't need to know why, but it's explained in that picture there if you want to read it. So just know that tidal forces can cause an object to move further away. This is, again, going to be very important because we're going to use this to explain how a planet can migrate. So we think that, for example, Jupiter, when it first formed, it was actually closer than what it is today. And because of these gravitational interactions, Jupiter has moved away from the Sun. So we'll talk about that in just a few moments. Okay, let's take a break, and when we come back, we're now going to talk about the different kinds of orbits that a planet can have.